Determine the uncertainties in results. When you're propagating uncertainties, you need to take into account of every uncertainty. So if you're adding / subtracting values to uncertainties, the absolute uncertainties must be added. If you're multiplying, dividing, or using exponents, then you add the percent uncertainties. With others, you find the highest and lowest possible value, and then you find the average uncertainty. Got lost? Well, let's do some examples. Say you have a barrette experiment, which we will never do in physics, but for video's sake, say we have a barrette. And I have an initial reading of 15.2 milliliters. And the absolute uncertainty for that is 0.1 milliliters. Now my final reading on this barrette is 3.2 milliliters plus or minus 0.1 milliliter. Now as stated before, I add the absolute uncertainties, which should give me plus or minus 0.2 milliliters. And with the regular values, I just subtract, which should get me 12.0 milliliters. Let's do another example. So say I'm trying to find the net acceleration of a block. Say this block is 9.21 kilograms. Say its uncertainty is 0.11%. Oh, lucky us. It's already derived in percent uncertainty. Well, let's say that this block is accelerating at a rate of 3.2 meters per second squared plus or minus 1.5%. That's a pretty fast block. Anyways, to find the net force, simply multiply the two values, which we get 29.472 newtons, plus or minus, adding the percent uncertainties, we should get 1.61%. And from here, we can easily derive the absolute uncertainty. For exponents, you're basically multiplying the same thing over and over again. So, you take the exponent and multiply it by the percent uncertainty. Say I have a cube with a side length of 4.0 centimeters, plus or minus 0.2%. And I want to find the volume. Well, cube. Take the exponent, multiply it by the percent uncertainty. I should get 64.0 centimeters cubed plus or minus 0.6%. Now for other functions, that's kind of tricky, but all you need to do is find the highest and lowest possible value, then find the average uncertainty. Say for example, I have a reading on a protractor, 50 degrees plus or minus 0.5 degrees. How can I find the uncertainty of sine theta? Well, first, let's take the highest possible value, sine of 50.5 degrees, which equals to 0.82. Now let's take the lowest possible value, which is sine of 49.5 degrees, which is equal to 0.71. Now, sine of 50 degrees is equal to 0.77. Now with these three values, I can take the highest and lowest possible value, subtract them, then divide them by 2 to find the average uncertainty. And with that, my final answer should be 0.77 plus or minus 0.06. The syllabus wants you to know that a simple approximate method rather than root mean square calculations is sufficient to determine maximum uncertainties. So no standard deviation. Boo bio.